As you settle in tonight, let's turn our gaze upward to humanity's oldest companion in the night sky, our moon. For as long as humans have existed, we've looked up at this luminous sphere, finding comfort in its presence. And tonight, as we explore its mysteries together, perhaps you'll discover why this celestial neighbor has captivated us for millennia. Our moon is far more ancient than you might imagine. Scientists have determined that it formed approximately 4.5 billion years ago, not long after Earth itself came into being. But the story of how it came to exist is one of cosmic violence and beauty intertwined. The leading theory, called the giant impact hypothesis, suggests that a Mars-sized object named Theia collided with the young Earth in a cataclysmic event. The debris from this tremendous impact, fragments of both Earth and Theia, eventually coalesced in orbit, slowly gathering together through gravity's patient pull to form the moon we see today. Imagine that for a moment. The moon is partly made from Earth itself, torn away in an ancient collision and reformed in the darkness of space. We are, in a very real sense, looking at a piece of our own planet every time we gaze at the moon. In those early days, the moon was dramatically closer to Earth than it is now, perhaps just 14,000 miles away, compared to its current average distance of about 238,855 miles. From Earth's surface, it would have appeared enormous in the sky, a looming presence many times larger than what we see today. And here's something that might surprise you. The moon is still moving away from us even now. Each year, it drifts approximately 1.5 inches farther from Earth, slowly and steadily increasing the distance between us. This happens because of tidal forces. The same forces that cause our ocean tides are gradually transferring energy in a way that pushes the moon outward in its orbit. This slow separation has profound implications. In those early epochs when the moon hung so much closer, Earth's days were much shorter, lasting perhaps only 5 hours. The moon's gravitational influence on Earth was so strong that our planet spun much faster. Over billions of years, as the moon receded, it acted as a brake on Earth's rotation through tidal friction, gradually slowing our spin until we arrived at our familiar 24-hour day. The moon's stabilizing influence extends beyond just the length of our days. Our moon is unusually large relative to its planet. It has a diameter of about 2,159 miles, making it the fifth largest moon in our entire solar system, and proportionally one of the largest compared to its host planet. This substantial size means it exerts a powerful stabilizing force on Earth's axial tilt. Earth currently tilts at about 23.5 degrees, and the moon's gravity helps keep this tilt relatively constant over long periods. Without the moon, Earth's tilt could vary wildly, swinging between 0 and 85 degrees over millions of years. Such dramatic shifts would create catastrophic climate changes, making it far more difficult for complex life to evolve and thrive. So as you rest here tonight, consider that the gentle light falling through your window may have played a crucial role in making life on Earth, including your own existence, possible. The moon's surface tells a story written in craters and plains, a testament to billions of years of cosmic history. The moon's surface tells a story written in craters and plains, a testament to billions of years of cosmic history. When you look up at the moon on a clear night, you can see dark patches scattered across its bright face. Ancient civilizations saw these patterns and imagined them as a face, a rabbit, or various other figures. But these dark areas, which we call Maria, the Latin word for seas, are actually vast plains of solidified lava. Between 3 and 4 billion years ago, during a period called the Late Heavy Bombardment, the moon was pummeled by asteroids and comets. Some of these impacts were so powerful that they cracked through the lunar crust, allowing molten lava from deep within to well up and flood enormous basins. This lava was darker than the surrounding highland rocks, and when it cooled and solidified, it created the dark patches we see today. The largest of these, Maria, Mare Imbrium, the Sea of Rains, stretches about 750 miles across, roughly the distance from New York to Chicago. These ancient lava flows reveal something remarkable about the moon's interior. Unlike Earth, which still has a molten core generating heat and volcanic activity, the moon is essentially geologically dead. It has a small, partially molten core only about 150 miles in radius, tiny compared to Earth's 2,200-mile wide outer core. The moon cooled far more quickly than Earth did, and its volcanic activity ceased billions of years ago. The Maria we see are frozen memories of the moon's last geological gasp. The craters that surround these dark plains are equally ancient. The moon's surface is scarred with approximately 500,000 craters larger than half a mile in diameter, and countless smaller ones. On Earth, weathering, erosion, and tectonic activity erase most impact craters over time. But the moon has no atmosphere to speak of. It's essentially a vacuum, which means there's no wind, no water, and no weather to wear these craters down. Each impact scar remains preserved, a permanent record of collision that might have occurred 3 billion years ago. This absence of atmosphere has other profound effects on the lunar surface. The sky above the moon is always black, even during what we'd call daytime, when the sun illuminates the surface. Stars are visible at all times because there's no atmospheric scattering to create a blue sky. And the temperature swings are extreme, ranging from about 260 degrees Fahrenheit in direct sunlight to negative 280 degrees Fahrenheit in the shadows. That's a difference of 540 degrees, all because there's no atmosphere to insulate the surface and moderate these extremes. Without an atmosphere, the moon is also constantly bombarded by micrometeorites, tiny particles that would burn up in Earth's atmosphere but strike the lunar surface directly. Over millions of years, this relentless bombardment, combined with radiation from the sun and cosmic rays, has ground the moon's surface rock into a fine powder. This powder, called regolith, covers the entire lunar surface to an average depth of about 15 feet. It's incredibly fine, almost like flour, and during the Apollo missions, astronauts found it clingy and abrasive, sticking to everything it touched. The footprints left by those 12 astronauts who walked on the moon between 1969 and 1972 remain there today, perfectly preserved in this regolith. With no wind or water to disturb them, those footprints could last for millions of years, silent testimony to humanity's first steps on another world. Soft transition. Perhaps the most familiar aspect of the moon is one we often take for granted. The fact that we always see the same face looking down at us. Perhaps the most familiar aspect of the moon is one we often take for granted. The fact that we always see the same face looking down at us. No matter where you are on Earth, no matter what time of year, the moon always presents the same features. The same dark Maria, the same bright highlands, the same ancient craters. This phenomenon is called tidal locking, and it's the result of billions of years of gravitational interaction between Earth and Moon. In its early history, the Moon rotated much faster on its axis, showing all of its sides to Earth as it orbited. But Earth's gravity created tidal bulges in the Moon's rocky body, much as the Moon creates tidal bulges in Earth's oceans. And over eons, these gravitational forces acted as a brake. Eventually, the Moon's rotation slowed until it matched its orbital period exactly, 27.3 days. Now the Moon rotates once on its axis in precisely the same time it takes to complete one orbit around Earth, keeping one hemisphere perpetually facing us. This means there's an entire far side of the Moon, often mistakenly called the dark side, that remained completely hidden from human eyes until 1959, when the Soviet spacecraft Luna 3 sent back the first grainy photographs. What those images revealed was surprising. The far side looks dramatically different from the near side. While the side facing Earth is marked with large, dark Maria, the far side is heavily cratered and has almost no Maria at all. Scientists believe this is because the crust on the far side is thicker, perhaps about 90 miles thick compared to 40 miles on the near side, making it much harder for ancient lava to break through and flood the impact basins. Why would one side of the Moon have a thicker crust? The answer may lie in those earliest days after the Moon's formation, when it was still molten. Earth's proximity and gravitational pull may have influenced how the cooling moon's materials distributed themselves, creating this asymmetry that persists to this day. As the moon orbits Earth, we experience its phases, the familiar cycle from new moon to crescent to full moon and back again. But these phases are simply the changing angles at which sunlight illuminates the moon from our perspective. A complete cycle through all the phases takes about 29.5 days, slightly longer than the moon's orbital period. This difference exists because as the moon orbits Earth, Earth itself is moving around the sun, so the moon needs a bit of extra time to return to the same position relative to the sun and Earth. During a new moon, the moon passes between Earth and the sun, with its sunlit side facing away from us, rendering it nearly invisible in our sky. Then, day by day, we see more of the illuminated surface as the moon continues its orbit, waxing from crescent to quarter to gibbous to full. At full moon, Earth is positioned between the moon and sun, and we see the entire sunlit face. Then the cycle reverses, waning back through gibbous, quarter, and crescent until the next new moon. These phases have governed human timekeeping for millennia. The word month itself derives from moon, and many ancient calendars, and some still in use today like the Islamic calendar, are based on the lunar cycle. Our ancestors planned their plantings and harvests, their festivals and ceremonies, around the moon's steady rhythm. Occasionally, during a full moon, Earth passes directly between the sun and moon in such a way that Earth's shadow falls across the lunar surface, creating a lunar eclipse. During totality, when the moon is completely within Earth's shadow, it doesn't go completely dark. Instead, it often glows a deep, coppery red, a phenomenon sometimes called a blood moon. This eerie red color occurs because Earth's atmosphere bends and filters sunlight, allowing red wavelengths to refract around Earth and illuminate the moon even while it's in shadow. All the sunrises and sunsets happening around Earth at that moment are, in effect, casting their light onto the moon. The moon's influence extends far beyond the light it casts into our nights. The moon's influence extends far beyond the light it casts into our nights. Its gravitational pull orchestrates one of Earth's most fundamental rhythms, the rising and falling of our ocean tides. Twice each day in most places around the world, the sea rises up the shore and then retreats again, a pulse as regular as breathing. This happens because the moon's gravity pulls on Earth's oceans, creating a bulge of water on the side of Earth facing the moon. But perhaps surprisingly, there's also a bulge on the opposite side of Earth, away from the moon. This occurs because the moon is actually pulling Earth itself slightly toward it, leaving the water on the far side behind. As Earth rotates through these two bulges during its 24-hour day, most coastal areas experience two high tides and two low tides. The sun also contributes to tides, though its effect is only about half as strong as the moon's, despite being vastly more massive. This is because tidal force depends not just on mass, but on distance, and the sun is nearly 400 times farther from Earth than the moon is. When the sun and moon align, during new and full moons, their gravitational pulls combine to create especially high spring tides, a term unrelated to the season, derived from the idea of water springing forth. When the sun and moon are at right angles to each other, during the quarter moons, they partially cancel each other out, creating gentler, neap tides. The difference in tidal range can be dramatic. In the Bay of Fundy between Nova Scotia and New Brunswick, the unique shape and depth of the bay funnels tidal water in such a way that the difference between high and low tide can reach over 50 feet, the highest tides on Earth. In other locations, the Mediterranean Sea for example, tides are barely noticeable, often just inches, because its narrow connection to the Atlantic restricts water flow. These tides have shaped life on Earth in profound ways. Tidal zones, those areas of coastline alternately covered and exposed by the tides, are among the most diverse and productive ecosystems on our planet. Countless species have evolved specifically to thrive in these challenging environments where they must survive both underwater and in open air. Beyond the oceans, the moon's gravity creates tides in Earth's atmosphere and even in the solid rock of Earth's crust itself. These Earth tides are subtle. The ground beneath you rises and falls by about 12 inches twice daily, but they're measurable and have effects ranging from triggering minor seismic activity to slightly affecting the precision measurements needed in particle physics experiments. The moon has no magnetic field today. If you were to stand on the lunar surface with a compass, it would be useless. However, rocks brought back by Apollo astronauts revealed something unexpected. They contain remnants of ancient magnetization, proving that the moon once had a magnetic field, perhaps 4 billion years ago when its core was still molten and churning. This magnetic field disappeared as the moon's interior cooled and solidified, leaving only these fossilized traces locked in lunar rocks. Without a magnetic field or atmosphere to protect it, the moon's surface is constantly bombarded by charged particles from the solar wind. A stream of particles flowing outward from the sun at about 1 million miles per hour. When these particles strike the lunar surface, they can actually cause atoms to be knocked loose and ejected into space, creating an incredibly thin halo of atoms around the moon. This is sometimes called the lunar exosphere, though it's so tenuous that it's barely distinguishable from a vacuum, about 100 trillion times less dense than Earth's atmosphere at sea level. Despite the harshness of its environment, the moon may harbor a precious resource: water ice. For decades, scientists suspected that in permanently shadowed craters near the moon's poles, places where sunlight has not reached for billions of years, temperatures might be cold enough for water ice to remain stable. These suspicions were confirmed in 2009 when NASA deliberately crashed a spacecraft into a polar crater and detected water in the debris plume. Subsequent observations have found evidence of ice deposits that could total hundreds of millions of tons. This discovery has profound implications not just for understanding the moon's history, but for humanity's future in space. This discovery has profound implications, not just for understanding the moon's history, but for humanity's future in space. Water on the moon could provide drinking water for astronauts, but more importantly, it could be split into hydrogen and oxygen. Oxygen for breathing and both elements as components for rocket fuel. The presence of water transforms the moon from merely a destination into a potential stepping stone for deeper space exploration. But let us return to those 12 remarkable individuals who walked on the lunar surface during the Apollo program. Between July 1969 and December 1972, 6 missions successfully landed astronauts on the moon. Neil Armstrong and Buzz Aldrin were first, spending just under a day on the surface during Apollo 11. By the final mission, Apollo 17, astronauts Eugene Cernan and Harrison Schmitt stayed for over 3 days, covering nearly 22 miles in their lunar rover and collecting over 240 pounds of samples. In total, the Apollo astronauts brought back 842 pounds of lunar rocks and soil. These samples have been studied intensively for more than 50 years and continue to yield new insights. Some are kept in special nitrogen-filled containers to prevent contamination. Others were deliberately left unopened, preserved for future generations of scientists who will have better tools and techniques to analyze them. It's a gift from the past to the future, a recognition that there is still so much we don't yet know how to discover. One of the most surprising things the Apollo astronauts reported was the smell of lunar dust. When they returned to their lunar module and removed their helmets, several astronauts noted that the dust clinging to their suits had a distinctive odor, described variously as smelling like spent gunpowder, wet ashes, or the air after a fireworks display. This smell came from the chemical reactions that occurred when the ancient, pristine lunar dust, which had never been exposed to oxygen, suddenly encountered the oxygen-rich atmosphere inside the spacecraft. The astronauts also discovered that moving on the moon felt unique. With gravity only 1/6 as strong as Earth's, each step became a gentle bound. Running was impossible in the traditional sense. Astronauts found that a hopping, loping gait was the most efficient way to move. In the reduced gravity, they weighed only about 60 pounds in their spacesuits, despite the suits themselves weighing around 180 pounds on Earth. Objects fell in slow motion, taking nearly 2.5 times longer to drop than they would on Earth. This reduced gravity has interesting implications. If you could jump straight up with enough force to reach 3 feet high on Earth, you could theoretically jump 18 feet high on the moon. A baseball thrown on the moon would travel about 6 times farther than on Earth before falling back down. Though without air resistance, its trajectory would be perfectly parabolic, never curving as it does when thrown through Earth's atmosphere. The Apollo missions left behind more than just footprints. Each landing site is scattered with artifacts. Lunar modules, descent stages that served as launch platforms, scientific instruments, American flags, discarded equipment, family photographs, and even golf balls. Alan Shepard famously hit 2 during Apollo 14. All of these objects remain exactly where they were left, untouched by time in the airless environment. The flags, however, have likely been bleached white by decades of unfiltered solar radiation, their colors long since faded under the harsh glare of the sun. Perhaps the most poignant artifact is a small plaque attached to the leg of the Apollo 11 lunar module, which remains on the moon's surface to this day. It reads, "Here men from the planet Earth first set foot upon the moon July 1969 AD. We came in peace for all mankind." Below this message are the signatures of the 3 Apollo 11 astronauts and President Richard Nixon. Since the end of Apollo, humans have not returned to the lunar surface, though that may soon change. Multiple nations and private companies are now planning lunar missions, including NASA's Artemis program, which aims to establish a sustainable human presence on and around the moon. As our understanding of the moon has deepened, so too has our appreciation for the subtle ways it shapes our experience of Earth. As our understanding of the moon has deepened, so too has our appreciation for the subtle ways it shapes our experience of Earth. The moon is responsible for one of nature's most breathtaking spectacles, the total solar eclipse. This cosmic coincidence exists because of a remarkable quirk of celestial geometry. The sun is about 400 times larger than the moon, but it's also about 400 times farther away from Earth. This means that from our perspective, the sun and moon appear almost exactly the same size in the sky. When the moon passes directly between Earth and the sun during a new moon, it can block the sun's disk completely, revealing the sun's ethereal corona, its outer atmosphere, which is otherwise invisible against the sun's overwhelming brightness. For a few precious minutes, day turns to twilight, stars emerge and the temperature drops. The shadow of totality is never more than about 170 miles wide, and it races across Earth's surface at over 1,000 miles per hour. If you've never experienced a total solar eclipse, the difference between 99% coverage and 100% totality is not incremental. It's transformative, an experience that has moved people to tears throughout history. But this perfect alignment is temporary on cosmic timescales. Remember that the moon is slowly drifting away from Earth at about 1.5 inches per year. In roughly 600 million years, the moon will be too far away to completely cover the sun. Future generations, if any exist, will never witness total solar eclipses as we can today. We live in a golden moment when our moon is at just the right distance to create this celestial wonder. The moon's surface holds other records of our solar system's history. Every impact crater is a frozen moment in time, and the pattern of cratering helps scientists understand the bombardment history of the inner solar system. The heavily cratered lunar highlands are the moon's oldest terrain, dating back over 4 billion years. By studying the density and size distribution of craters in different regions, scientists can estimate the age of lunar features and piece together the timeline of impacts that shaped not just the moon, but Earth as well. Though on Earth, most of this ancient record has been erased by geological activity. One of the most famous lunar craters is Tycho, a relatively young crater only about 108 million years old. From Earth, even with modest binoculars, you can see the spectacular ray system radiating from Tycho, bright streaks of ejected material that extend for hundreds of miles across the lunar surface, appearing as light-colored lines against the darker lunar plains. These rays are brighter than the surrounding terrain because the impact excavated fresh material from beneath the surface, material that hasn't been darkened by billions of years of micrometeorite bombardment and solar radiation. The moon experiences moonquakes, seismic events similar to earthquakes but far weaker. During the Apollo missions, astronauts installed seismometers that operated for years, detecting thousands of these moonquakes. Some are caused by meteorite impacts or by thermal stress as the lunar surface expands and contracts with the extreme temperature changes between lunar day and night. But the most intriguing are deep moonquakes, occurring about 430 miles below the surface, likely caused by tidal stresses from Earth's gravitational pull on the moon's interior. These deep moonquakes occur in regular patterns, clustered at specific points in the moon's orbit when tidal forces are strongest. Interestingly, moonquakes can last much longer than earthquakes. An earthquake typically lasts less than a minute, with vibrations dying away quickly as Earth's crust absorbs the energy. But moonquakes can continue for over 10 minutes, with the moon ringing like a bell, because the dry, rigid, and fractured lunar crust transmits seismic waves efficiently rather than dampening them. This difference revealed something important about the moon's structure. It's cold, solid, and brittle throughout most of its interior. The moon has inspired humanity in ways that transcend science. It has been a symbol in every culture, woven into mythology, religion, poetry, and art. Ancient civilizations built monuments aligned with lunar cycles. The Mayans tracked the moon's movements with extraordinary precision. Islamic calendars follow the lunar cycle, beginning each month with the sighting of the new crescent moon. The Chinese Mid-Autumn Festival celebrates the full moon as a symbol of reunion and harmony. In literature and music, the moon appears as muse and metaphor, a symbol of romance, madness, transformation, and longing. The very word lunacy derives from the Latin word for moon, luna, reflecting the ancient belief that the full moon could affect human behavior and mental state. While scientific studies have largely debunked the idea that the moon significantly influences human psychology or behavior, the cultural association persists, testament to how deeply the moon is embedded in human consciousness. Looking ahead, the moon represents not just our past but potentially our future. Looking ahead, the moon represents not just our past, but potentially our future. Plans are underway to establish a permanent human presence there, not just for exploration but as a proving ground for the technologies and systems needed for even more ambitious journeys. A lunar base could serve as a laboratory for learning to live off-world, testing systems for growing food, recycling water and air, and protecting humans from radiation in ways that would be far more difficult to attempt on distant Mars. The moon's south polar region has become a focal point for these ambitions. There, some crater rims receive sunlight almost continuously, areas known as peaks of eternal light, while nearby crater floors remain in perpetual shadow, cold enough to trap water ice. The combination of near-constant solar power and accessible water ice makes this region incredibly valuable. Multiple nations, including the United States, China, India, and Russia, have announced plans to explore or establish bases in this area. But the moon is not just a destination for governmental space agencies. Private companies have also set their sights on lunar exploration and resource utilization. Some envision mining operations to extract valuable materials. The lunar regolith contains helium-3, a rare isotope that could potentially fuel future nuclear fusion reactors. While fusion power remains theoretical, some estimates suggest that a single space shuttle cargo bay full of helium-3 could power the entire United States for a year. The moon's surface holds more helium-3 than exists on Earth, deposited over billions of years by the solar wind. Yet as we contemplate a future of lunar development, questions arise about preservation and protection. The Apollo landing sites, for instance, are not just historical locations, they're archaeological sites representing humanity's first steps beyond Earth. There are currently no binding international laws protecting these sites, though various proposals have been made to establish lunar heritage sites, similar to UNESCO World Heritage Sites on Earth. The 1967 Outer Space Treaty, signed by over 110 nations, establishes that no country can claim sovereignty over the moon or any other celestial body. The moon, in the words of the treaty, is the province of all mankind. However, the treaty doesn't address questions about resource extraction or commercial activities, leading to ongoing debates about the legal framework for lunar development. The moon continues to reveal surprises. In 2020, NASA announced the detection of water molecules on the sunlit lunar surface, not just in permanently shadowed craters but across broader areas. This water exists in concentrations roughly equivalent to a 12-ounce bottle of water trapped within a cubic meter of soil. Scientists believe this water might be created when hydrogen from the solar wind combines with oxygen in lunar minerals, or might be delivered by micrometeorites containing water. It could be trapped in tiny glass beads formed by meteorite impacts, or locked within the crystal structure of minerals, protected from evaporating into space. Understanding the moon's geology has also helped us understand Earth's early history. Because Earth's geological activity has destroyed most evidence of its first billion years, the moon serves as a kind of time capsule. The ancient rocks of the lunar highlands preserve information about conditions in the early solar system. By studying how the moon formed and evolved, scientists gain insights into Earth's own violent birth and early development. The moon even helps us understand other moons in our solar system. Our moon is unusual. Most moons in the solar system are tiny compared to their parent planets. Jupiter's moon Ganymede and Saturn's moon Titan are both larger than our moon, but they're minuscule compared to their giant planetary hosts. The Earth-Moon system is more like a double planet than a typical planet-moon pairing. This unusual relationship has implications for understanding how planetary systems form and evolve throughout the universe. Recent missions from various nations continue to expand our knowledge. China's Chang'e 4 mission achieved the first-ever soft landing on the far side of the Moon in 2019, deploying a rover to explore this rarely studied region. India's Chandrayaan missions have mapped lunar minerals and searched for water ice. Japan has sent spacecraft to study the Moon's origins and composition. As we drift toward rest, consider the quiet constancy of the Moon's presence. As we drift toward rest, consider the quiet constancy of the Moon's presence. For all of human history, and for countless eons before, the Moon has been rising and setting in an eternal rhythm. This rhythm is not quite as simple as it might seem, however. The Moon rises about 50 minutes later each day, shifting its appearance in our sky throughout the month. Sometimes it rises during daylight hours, visible as a pale ghost against the blue sky. Other times it climbs above the horizon in deep twilight or the darkness of night. Near the horizon, the Moon often appears enormous, much larger than when it's high overhead. This is the famous moon illusion, a trick of human perception rather than any actual change in the Moon's size. Scientists still debate the exact cause, but it likely involves how our brains interpret size and distance when we see the Moon near familiar objects like trees and buildings on the horizon, compared to when it hangs isolated in the empty sky above. Photographs reveal the truth. The Moon's apparent size remains constant regardless of its position in the sky. The Moon's orbit around Earth is not a perfect circle but an ellipse, meaning its distance from Earth varies throughout each orbit. At its closest point, called perigee, the Moon is about 225,623 miles away. At its farthest point, apogee, it's about 252,088 miles distant. When a full moon coincides with perigee, we get what's popularly called a supermoon, appearing about 14% larger and 30% brighter than a full moon at apogee. While the difference is subtle to casual observers, the effect is real and measurable. This elliptical orbit also causes the Moon to appear to wobble slightly as seen from Earth, a phenomenon called libration. Although the Moon is tidally locked and rotates at the same rate as it orbits, libration allows us to see slightly more than half of the lunar surface over time. Through various librations, caused by the elliptical orbit, the tilt of the Moon's axis, and our changing perspective as Earth rotates, we can actually observe about 59% of the Moon's surface from Earth. The remaining 41% remained completely hidden until spacecraft traveled behind the Moon to photograph it. Throughout the month, the Moon's rising and setting times shift in fascinating patterns. During winter in the northern hemisphere, a full moon rises in the northeast, climbs high across the sky, following a path similar to the summer sun, and sets in the northwest, remaining above the horizon for many hours. In summer, by contrast, the full moon stays low, skimming just above the southern horizon. This happens because the full moon is always opposite the sun in the sky, so when the sun traces its low winter arc, the full moon traces a high path and vice versa. Ancient peoples recognized these patterns and used them for navigation and timekeeping with remarkable sophistication. The Polynesians navigated thousands of miles of open ocean using the moon, stars, wave patterns and other natural signs. Farmers in many cultures planted crops according to lunar phases, a practice that persists in some places today, though scientific evidence for the moon's influence on plant growth remains inconclusive. The moon's gravitational influence extends to some surprising phenomena. The moon's pull actually causes Earth's shape to bulge slightly, not just the oceans but the solid Earth itself deforms. GPS satellites must account for these tiny movements to maintain their accuracy. Even particle accelerators like the Large Hadron Collider must adjust for Earth tides caused by the moon, as the subtle stretching and compressing of Earth's crust can affect the accelerator's 17-mile ring by millimeters, enough to matter at the subatomic scales where physicists work. In recent years, scientists have discovered that the moon generates its own faint light beyond just reflecting sunlight. When charged particles from Earth's magnetosphere strike the lunar surface, they can cause it to glow very faintly, a phenomenon detectable only with sensitive instruments. This glow is most prominent during the full moon when the moon passes through Earth's magnetotail, a region where Earth's magnetic field is stretched out by the solar wind. The moon has also served as an unexpected mirror for studying Earth itself. Scientists have analyzed Earthshine, sunlight that reflects off Earth, bounces to the moon and then reflects back to Earth, to study our planet's clouds and atmosphere. By observing how Earthshine changes, researchers can monitor changes in Earth's reflectivity and cloud cover, providing another tool for understanding our climate. Perhaps most remarkable is simply that the moon is there at all. Perhaps most remarkable is simply that the moon is there at all. When we look out at our solar system, we find that Earth is the only rocky planet with such a large, substantial moon. Mars has two tiny moons, Phobos and Deimos, but they're more like captured asteroids, irregular chunks of rock only a few miles across. Venus and Mercury have no moons whatsoever. Only Earth, among the terrestrial planets, has a companion that could truly be called a moon in the grandest sense. This singularity may have been crucial for life on Earth. Beyond stabilizing our axial tilt and creating tides, the moon may have played other vital roles. Some scientists theorize that the moon's formation, that cataclysmic collision with Theia, may have stripped away much of Earth's early, toxic atmosphere and delivered materials that contributed to the formation of Earth's protective magnetic field. The collision's energy may have helped set Earth's rotation and created the conditions necessary for plate tectonics, which recycle carbon and regulate Earth's climate over geological timescales. Even the moon's simple presence in our night sky may have influenced the evolution of life in subtle ways. Moonlight, while much dimmer than sunlight, about 400,000 times fainter, is still bright enough to cast shadows and allow many animals to see and navigate at night. Countless species have evolved behaviors synchronized with lunar cycles. Sea turtles use the moon's light to find the ocean after hatching. Corals spawn in sync with lunar phases. Some species of dung beetles navigate using the light of the moon. The natural world pulses to lunar rhythms we're only beginning to fully understand. The moon's surface temperature extremes create another curious phenomenon. During the 2-week lunar day, as the sun slowly tracks across the black sky, the surface heats to those blistering 260 degrees Fahrenheit. Then, during the equally long lunar night, temperatures plummet to 280 degrees below zero. This means that at the terminator, the line dividing lunar day from lunar night, there exists a narrow band where temperatures might be relatively moderate, creating what some call a twilight zone that slowly migrates around the moon. One of the Apollo program's most iconic images is known as Earthrise, a photograph taken by astronaut William Anders during Apollo 8's orbit of the moon on Christmas Eve, 1968. The image shows Earth appearing to rise above the stark, gray lunar horizon, our blue and white world floating in the black void of space. This was the first time humans had photographed Earth from another celestial body, and the image profoundly affected how humanity viewed our planet. Small, fragile, and precious against the vast emptiness of space. The environmentalist movement, which gained momentum in the 1970s, drew inspiration from this new perspective. From the moon's surface, Earth appears nearly 4 times larger in diameter than the moon appears from Earth, and with Earth's clouds, oceans, and continents, it's far more visually striking. But unlike the moon as seen from Earth, Earth doesn't rise and set in the moon's sky. Remember, the moon is tidally locked. The same side always faces Earth. This means that from any given spot on the near side of the moon, Earth hangs perpetually in approximately the same position in the sky, though it goes through phases just as the moon does when viewed from Earth. From the moon's far side, Earth is never visible at all, hidden forever beyond the horizon. Astronauts who stood on the moon described the profound silence of the place. With no atmosphere to carry sound, the moon is utterly silent. Footsteps make no sound. Rocks struck together produce vibrations but no audible noise unless you're touching them. The only sounds were those transmitted through their suits, their own breathing, the hum of life support systems, and voices crackling over the radio. It was, several astronauts reflected, like standing in the most perfect vacuum imaginable, because that's exactly what it was. The dust that covers the moon posed unexpected challenges. Being formed by billions of years of meteorite impacts rather than by water and wind erosion, lunar dust particles are sharp and jagged rather than smooth and rounded. This made the dust abrasive. It wore through layers of the astronauts' spacesuits, scratched helmet visors, and jammed mechanical seals. Some astronauts reported mild respiratory irritation from the tiny amount of dust that inevitably made its way into the lunar module. Future missions will need better dust management systems. Despite decades of study, the moon continues to puzzle scientists in small ways. For instance, mysterious flashes of light called transient lunar phenomena have been reported by observers for centuries. These brief flashes or glows, lasting from seconds to hours, might be caused by outgassing from the lunar interior, or perhaps by meteorite impacts or electrostatic charging of dust, but their exact cause remains uncertain. As you settle deeper into comfort, imagine standing on the moon's surface in the perfect stillness. As you settle deeper into comfort, imagine standing on the moon's surface in the perfect stillness. Above you, Earth hangs like a brilliant jewel, blue oceans swirling with white clouds, brown and green continents slowly rotating into view. The stars around it don't twinkle as they do on Earth. Without an atmosphere to distort their light, they shine with steady, unwavering brilliance. The Milky Way stretches across the black sky in a river of light more vivid than anything visible from Earth's light-polluted surface. The horizon on the Moon is surprisingly close. Because the Moon is so much smaller than Earth, with a diameter only about 1/4 of Earth's, the horizon is only about 1.5 miles away when you're standing on level ground. On Earth, the horizon is roughly 3 miles distant. This means the Moon's surface curves away noticeably faster, giving the small world a more intimate, enclosed feeling despite the vast emptiness surrounding it. Astronauts reported that this closeness of the horizon made the Moon feel simultaneously tiny and infinite. Walking across the lunar surface, you would encounter regolith that records an incredible span of time. Some of the dust particles beneath your feet might be as old as the solar system itself, 4.5 billion years old, while others could have been created yesterday by a micrometeorite impact. Each grain carries the history of its formation and transformation, a microscopic archive of cosmic events spanning eons. The Moon's lack of geological activity means it preserves craters from objects of all sizes. The largest confirmed impact basin on the Moon is the South Pole Aitken Basin on the far side, stretching about 1,600 miles in diameter and plunging more than 5 miles deep. It's one of the largest impact craters in the entire solar system, likely formed over 4 billion years ago when an asteroid the size of a small state struck the Moon with unimaginable force. The impact was so violent it may have punched through the lunar crust entirely, exposing material from the Moon's mantle, giving scientists a rare window into the Moon's interior composition. Temperature measurements of the lunar surface have revealed another mystery. Certain areas retain heat longer than expected after sunset. These thermal anomalies appear as warm spots in infrared images during the lunar night. Scientists believe these areas might contain rocks with different thermal properties than the surrounding regolith, or they might be locations where the surface is more compacted. Understanding these anomalies helps researchers identify promising landing sites and understand the Moon's surface properties. The Moon has no weather, yet its surface is not entirely static. The solar wind constantly bombards the surface, and this bombardment, combined with the extreme temperature cycling and the occasional meteorite impact, causes the very surface of exposed rocks to slowly erode and form what's called a space weathering layer. This process darkens the surface over time, which is why fresh craters and their bright ray systems stand out so dramatically. They've excavated material that hasn't yet been darkened by space weathering. On Earth, we're protected from the radiation of space by our magnetic field and atmosphere. On the Moon, astronauts were exposed to much higher radiation levels. Not dangerous for short missions, but a significant concern for long-term lunar habitation. A year on the Moon's surface would expose someone to roughly 380 millisieverts of radiation, comparable to getting about 380 chest X-rays. Future lunar bases will need substantial shielding, perhaps built underground or covered with several feet of lunar regolith to protect inhabitants. The Apollo missions demonstrated that humans could survive and work on the Moon, but they also revealed how hostile the environment truly is. Spacesuits must be pressurized, climate-controlled, and provide oxygen. They must protect against radiation, temperature extremes, and the abrasive dust. The suits used during Apollo weighed 180 pounds on Earth but only 30 pounds on the Moon, yet they were still cumbersome and tiring to work in. Astronauts reported that even simple tasks required significant effort, and they would quickly become exhausted. Yet despite these challenges, the Moon exerted an almost magical pull on those who visited. Every Apollo astronaut who walked on the lunar surface spoke of the profound impact the experience had on them. Edgar Mitchell of Apollo 14 described a sense of overwhelming connection to the universe. Alan Bean of Apollo 12 became an artist, spending the rest of his life painting lunar scenes, trying to capture the indescribable beauty he witnessed. And now, as your own breathing slows and steadies, the Moon continues its ancient dance above. And now, as your own breathing slows and steadies, the Moon continues its ancient dance above. For over 4.5 billion years, it has circled Earth in patient devotion, a silent guardian watching over our world through ice ages and extinctions, through the rise of life from the oceans and the eventual emergence of beings who could look back and wonder at its existence. The Moon has witnessed everything: the first stirrings of single-celled organisms in Earth's primordial seas, the greening of the continents, the age of dinosaurs, and their sudden disappearance. It saw the first humans emerge in Africa, watched as they spread across every continent, built civilizations, and finally developed the technology to visit the moon itself. And through all of this, the moon simply continued its orbit, unchanging and eternal in the sky. In a sense, the moon is a mirror of deep time. When you look at the moon tonight, you're seeing a world that has remained essentially frozen for billions of years. The footprints left by the Apollo astronauts in 1969 will still be there a million years from now, perhaps even recognizable. The craters visible tonight are the same craters that dinosaurs might have glimpsed if they looked up 100 million years ago. This changelessness gives the moon a quality of timelessness. It connects us to the deep past and the distant future simultaneously. The moon also represents possibility. It's the only world beyond Earth that humans have touched with their own hands. Those 12 individuals who walked on its surface proved that humanity is not forever bound to this one planet. They showed that with ingenuity, courage, and determination, we can extend our reach beyond our atmospheric cradle. The moon is both a destination and a symbol, a reminder that the universe, for all its vastness and inhospitability, is not entirely beyond our grasp. As you lie here now, the moon is somewhere in its monthly journey, perhaps rising in the east, perhaps already high overhead, perhaps setting in the west or hidden from view on the far side of Earth. Wherever it is, it continues pulling at Earth's oceans, creating the tides. It continues its slow drift outward, millimeter by millimeter. It continues collecting the gentle rain of cosmic dust and the occasional meteorite impact. The moon is patient. The moon endures. Ancient peoples saw the moon as a deity, and perhaps there was wisdom in that reverence. Not because the moon is supernatural, but because it truly does govern aspects of our world. The tides, the length of our days, the stability of our seasons. It illuminates our nights and inspires our dreams. It's the only celestial object close enough that we can see its features with the naked eye, close enough that we can imagine standing on its surface and looking back at home. In many ways, understanding the moon has helped us understand ourselves. The moon taught us that worlds can form from violent collisions and yet settle into stable, beautiful systems. It taught us that even small bodies can have enormous influences on their companions. It showed us that the past is preserved in places where time moves differently than it does on our dynamic, living world. And it reminded us that we are part of something much larger. A solar system, a galaxy, a universe filled with wonders we're only beginning to comprehend. Tonight, wherever you are, the moon is somewhere between 225,000 and 252,000 miles away, impossibly distant by human standards, yet close enough that we reached it with 1960s technology. Close enough that you can hold up your thumb and completely hide it from view. Close enough that its light reaches your eyes in just over a second, having bounced off that ancient, dusty surface. That light left the sun 8 minutes ago, traveled 93 million miles to the moon, reflected off regolith that might have been undisturbed for a billion years, and then traveled the 250,000 miles to reach you. In a very real sense, you are connected to the moon through this thread of light, joined by photons that carry information about that distant world directly to you. And as you rest now, let yourself float on the thought of the moon's eternal presence. Always there, always watching, always circling, a companion to Earth, a light in the darkness, pulling gently at the oceans, drifting slowly away, but still here tonight, and tomorrow night, and for countless nights to come.